Hello all. So in today's class we'll see a few more problem on linear independence and dependence. So before going into the problem, so let us see one more note on the linearly independent and dependent function. So if you have, so the note states that so if you have vector functions phi1, phi2, etc., phi m, and if they are linearly dependent in a given interval, in a closed in an interval, so you have a less than or equal to t less than or equal to b. Once this vector functions phi1, phi2 and phi m, provided they are linearly independent on the interval a less than or equal to t less than or equal to b, then when you take c1 phi1 plus c2 phi2 plus etc. cm phi m, so when they are linearly dependent, not all the CAs are 0. Now when the functions are linearly independent, so provided we take any t naught belongs to AB, so here we are taking a fixed value t naught belongs to AB. So at t naught, so when you take phi1 of t naught, phi2 of t naught and etc. phi m of t naught, so we can see that these are actually constant vectors. So this is a vector function. In fixed t naught edukkumbo and kitana phi1 of t naught, phi2 of t naught, etc. Phi m of t naught, they are constant vectors, and these vectors are also going to be linearly dependent. So if you have linearly independent vector functions phi1 and phi2, phi1, phi2, etc. phi m in a closed interval AB, then for any fixed t naught belongs to AB, the constant vectors phi1 of t naught, phi2 of t naught, phi m of t naught will be again linearly dependent. But analogously, when you take for linearly independent vector functions, that is not the case. For phi1, phi2, phi m, if they are linearly independent, then when you take a fixed t naught, they need not be independent again. Ad chelapam dependent aava. So that is our note. So analogously, if you are taking phi1 of t naught, phi2 of t naught, etc., phi m of t naught. So this is a case where phi1, phi2, etc., phi m are linearly independent. So when you take phi1 of t naught, phi2 of t naught and phi m of t naught, so for a fixed t naught, എപ്പോഴും ഇത് ഇൻഡിപെൻഡന്റ് ആവണം നിർബന്ധമില്ല. This can be dependent also. So that is our note. So unlike the dependent functions, this is not necessarily true for the independent functions. So let us write that note and let us see an example on that. So if the set of n vectors, vector functions phi1, phi2, etc. phi m is linearly dependent on an interval a less than or equal to t less than or equal to b, then for each fixed t naught belongs to closed interval AB, the corresponding set of m constant vectors phi 1 of t naught, phi 2 of t naught, etc. Phi m of t naught is linearly dependent however in the analogous statement for the set of m linearly independent vector functions is not valid. That is, if a set of vectors, set of m vector functions, so phi 1, phi 2, etc. Phi m is linearly independent on an interval a less than or equal to t less than or equal to b, then it is not necessarily true that for each fixed t naught belongs to AB, the corresponding set of m constant vectors phi 1 of t naught, phi 2 of t naught, etc. Phi m of t naught is linearly independent. So the corresponding set of vectors phi 1 of t naught, etc. Phi m of t naught may be linearly dependent. So we will see an example of this. So the vector functions, when you take as such, they are linearly independent, but when you take the corresponding constant vectors, so when you fix the value for t, they are linearly dependent. So let us see an example. So consider the vector functions phi 1 and phi 2 defined by phi 1 of t equal to 1 t1 and phi 2 of t equal to t e raised to t and e raised to t respectively, and show that the constant vectors phi 1 of t naught and phi 2 of t naught are linearly dependent for each t naught in the interval 0 less than or equal to t less than or equal to 1, but the vector functions phi 1 and phi 2 are linearly independent non-zero less than or equal to t less than or equal to 1. So you need to show that phi 1 and phi 2 are linearly independent, but for a fixed t naught, when you take phi 1 of t naught and phi 2 of t naught, they are linearly dependent. So let us see the solution. So consider, so first you will show that phi 1 and phi 2 are linearly independent. So consider the vector functions phi 1 equal to t1 and phi 2 equal to t e raised to t and e raised to t. So when you take c1 t1 plus c2 t raised to t e raised to t equal to 0. So that implies c1t plus c2 t raised to t equal to 0, and you will get c1 plus c2 e raised to t equal to 0. So the first equation t will cancel off, so remaining you are going to get the equation c1 plus c2 e raised to t equal to 0. So we are given an equation in the form c1 f1 plus c2 f2 equal to 0. So we need to find the value of c1 and c2 which satisfies this equation. നമുക്ക് ഈ പ്രോബ്ലം എന്ന് പറയുന്നത് that is equivalent to checking whether, so we can check whether the functions f1 and f2 are linearly independent. So let us look at what is the Wronskian of the functions 1 and e raised to t. So that is going to be the determinant 1 e raised to t and 0 e raised to t. So this is going to be e raised to t, which is not equal to 0. So that implies the functions 1 and e raised to t is linearly independent. Now if this is linearly independent, so that implies c1 equal to c2 equal to 0. So therefore the vector functions phi 1 and phi 2 are linearly independent. Phi 2 of t naught is t naught e raised to t naught and e raised to t naught. So again let us look at c1. So that is t naught 1 plus c2 t naught e raised to t naught e raised to t naught equal to 0. So that gives us the equation t naught c1 plus t naught e raised to t naught c2 equal to 0, and c1 plus c2 e raised to t naught equal to 0. So this is a linear system of equation. So when you take the coefficient matrix will be, so coefficient matrix is equal to t naught e raised to t naught, then 1 e raised to t naught. So when you take the determinant of A, that will be t naught e raised to t naught minus t naught e raised to t naught, so which is equal to 0. So this is equal to 0 implies the system has a non-trivial solution. So that implies not all Ci's are 0. So that implies phi 1 of t naught and phi 2 of t naught are linearly dependent. So we have got that phi 1 of t and phi 2 of t, they are linearly independent, but phi 1 of t naught and phi 2 of t naught are linearly dependent.